We start this section looking at the idea of sampling distributions. We'll look at them for means and proportions, two of the big statistics that we calculate in this class. And so the first thing I wanted to think about is remind you why we study statistics. And remember, statistics is the study of us, and what we do is we try to make inferences about a population, right? A population of interest. And we do that through samples. We take samples to understand the population. So a question to think about: what is the mean number of people a person with COVID-19 can infect? Right, that's a legitimate question nowadays, thinking about if someone is sick, how many people would they actually infect? And that value is called R0 in the real world, and really is the virus's basic reproductive number. Right, so if the value is 3, that means someone who gets sick on average will infect 3 people. And so kind of that's the idea we're looking at when thinking about coming up with what we call an estimator for the population parameter. In this case, that value would be an estimate for the number of people someone would infect. And when we talk about estimator, right, we're using the statistics, right, from a sample to estimate the value of a parameter from the population. And what we care about is that the data is accurate and precise. So imagine we're trying to estimate how many people, right, what is the value on average that a person infects, the number of people they infect if they have COVID-19, right? The mu would be in the middle, right? That's the actual value, which we don't know. And if we have an estimate, we want it to be accurate and precise. Here's an example here, this first one here. This is an example of being accurate but not precise, right? It's kind of close to it, but it's not precise on the mu, the mean. Here's one that's precise but not accurate, right? It's all kind of in the same place, our estimates, but they're not actually accurate. Versus this case here where we see it's accurate and precise. And that's what we're looking for an estimator. We don't want an estimator to be inaccurate and not precise. And again, that's the importance of why we do many of the things in statistics that we do, right, in the sense of how we collect the data, how we make it random, right? And so what we're looking at here is, again, what an estimator is. And we have certain things about an estimator. Sometimes an estimator is biased, right? When it's not accurate, the aim is off. It's called a biased estimator. Additionally, we have that's the bias. That we have the unbiased estimator, which is it's accurate. It's correctly centered on a population parameter of interest. We call it unbiased. It's going to be accurate and precise. And so we're going to put all this together with this section and study this idea of a sampling distribution, right? And it's the distribution of a statistic, the sampling distribution of X bar, right, of the sample mean, which show all the possible values of X bar can take given some sample size and how often we see it. So imagine doing a sample from a population and doing it multiple times. What would that distribution look like if we did multiple samples, not just one sample of 10, right? Let's say we did 30 samples of 10. What would that distribution look like? And that's what we're going to study here.